Today we're going to look at Unit 11, Section 4, which deals with surface area and volume of three-dimensional shapes, talking about the ratio of similar shapes, also what happens when one side or multiple sides change. Alright, so similar polygon review. Let's talk about what it means for shapes to be similar. Two shapes are similar. Their sides form a scale factor. So here, smallest over smallest, 3 over 6. Largest over largest, and the middle over middle. And if I reduce every single one of these, they all reduce to the same scale factor of 1 over 2. That's what it means to be similar. You have the same scale factor. It's basically, I just took this image and I enlarged it, or I took this image and I shrunk it. This applies when we're dealing with three-dimensional shapes. These have a scale factor. I use the same numbers. Look, smallest over smallest, 3 over 6, 4 over 8, 5 over 10. These shapes have a scale factor of their sides of 1 over 2. But what's the scale factor of their surface area? Well, we know the scale factor of their sides is 1 over 2. Let's plug in the formula. Let's find out the surface area. 2 times length width, 2 times length height, plus 2 times width height. Multiply all of that, you get 94. Surface area of this one, 2 times length width, plus 2 times length height, plus 2 times width height. So I do all of that, and I get 376. So our ratio is 94 over 376. This reduces to 1 over 4. So our scale factor of our sides is 1/2, but our scale factor of the surface area is 1/4. But what about the volume? Volume, length times width times height. The volume of this shape is 60. Length times width times height. The volume of this shape is 480. Scale factor of the sides is 1/2. Scale factor of the volumes, 60 over 480, reduces to 1 over 8. So this leads us to what the relationship between the sides and the area and volume. So here's 2 examples. Scale factor is 2/3, scale factor is 4, or you can think of that as 4 over 1. The scale factor of the surface area is the scale factor of the sides squared. So 2 squared, 3 squared, 4 squared, 1 squared. The volume scale factor is the scale factor of the sides cubed. Scale factor cubed. So 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 27. 4 cubed, 64. So the surface area, you square it. The volume, you cube it. Now, we're going to use this idea and we're going to figure out, well, why does this happen? And we're going to look at that in 3 examples. This first example, what's happening here is I increased the height. Look, I went from 5 to 15. That's all that I changed. So let's look at the volume. The volume of this when you plug it into your formula, 1/3 big B, so that's 10 times 10, times the height, which is 5, I get the volume, it's 166.6 repeating. Now I increased it by 3. So the volume here, 1/3 big B, 10 times 10, is 100, times the height, 15. I do all of that and I get 500. Now what happened here, why this volume is only 3 times larger, is because all I did is I changed one dimension. The height, I changed one dimension. Let's look at another example. Here, my height stays the same, and I'm changing the base. The base goes from 10 to 20. So volume, 1/3 big B times the height. We know that's 166.6 repeating. Here, volume's 1/3 big B, 20 times 20. Notice I've now changed 2 dimensions, 20 and 20. So that's 400 times the height of 5. And what I get from my volume here is I get 600.6 repeating, 666.6 repeating. So my volume was more than doubled. I increased this dimension by 2, I increased this dimension by 2. 2 times 2 is 4. I increased it 4 times. This gave me this. Now this is leading us to the next example. What happens when I change all of my sides by the same ratio? Doubled, height, doubled. This is getting to our scale factor idea. Volume, we know, is 166.6 repeating. This one, volume, 1/3 big B, 20 times 20, 400, times the height of 10, and I get 1,333 for my volume. What happened was my volume was increased by my scale factor cubed. My scale factor was 1/2, so my scale factor volume is cubed 1/8. So this times 8 gives me my new volume. So let's look at another example. And this time, I'm going to do it a little bit easier. I'm not actually going to do the surface area and volume of this shape. I'm going to do everything using scale factors. The volume and surface area of this shape, surface area, 2 pi r, r plus h. So the surface area ends up being 80 pi. Volume, pi r squared h. So 4 squared times the height, and I get the volume is 96 pi. My ratio, my scale factor, 4, 8, 6, 12, is 1/2. So my surface area, square it, 1/4, volume, cube it, 1/8. So to find the surface area, I'm going to times this by 4. To find the volume, I'm going to times this by 8. So I get 320 pi for the surface area, 80 times 4. And then for the volume, I get 768 pi, which is 96 times 8. So that's the idea of surface area and volume in relationship to our scale factor of similar three-dimensional shapes. I'll see you next class.